Hello students, welcome to my Abhyas. My name is Sahana KS and I am your physics educator. So in this session we'll continue with the numericals and we'll end the numericals in this session today. Okay, and in the further sessions we'll start with the competitive exam questions. So be ready and be thorough with all the academics, whatever I have taught you. So we'll be discussing about the questions from KCET, JEE and also NEET. Okay, so moving on to the next question, what is it? So there is a question, a very easy one, and you can solve it and it has to be logically treated also. So first thing is a point charge of 2.0 microcoulomb. So there is a point charge of 2.0 microcoulomb and it is at the center of a cubic Gaussian surface. So in the cubic Gaussian surface, it is at the center of how much? 9 centimeter on edge. Okay. What is the net electric flux through the surface? So I have to find out the net electric flux. So what is the formula of flux I have? It is phi is equal to q divided by epsilon naught. I know the charge, I know epsilon naught, and they have given me 9.0 centimeters, that is which is the, you can say the Gaussian surface, that is the cubic Gaussian surface length it is. Okay. So you can say this as R, you can take this as R. And what is the net electric flux through the surface? I have to find out. So we'll do the solution. So solution comes to be, first write down what they have given us. So what they have given us the charge Q is equal to 2.0 microcoulomb or 2.0 into 10 raised to minus 6 coulomb. Right, it is 2.0 microcoulomb or 2.0 into 10 raised to minus 6 coulomb. And in the next case, what they have given us the length, or R I can say 9.0 centimeter or 9 into 10 raised to minus 2 meters. Okay, so that is how it is given. And next thing what I have to do, I have to find out the phi, that is the electric flux through the surface. So phi is equal to q divided by epsilon naught. The value of q is nothing but it is 2 into 10 raised to minus 6 divided by, what about epsilon naught? It is 8.85 into 10 raised to minus 12. Okay, it is epsilon naught value is 8.85 into 10 raised to minus 12. Q value is 2 into 10 raised to minus 6. So solving this, I'll get around 2.26 into 10 raised to minus 12 goes up. So minus 12, that is plus 12 minus 6. What happens? I'll get it around 5 Newton meter square per coulomb, which is the flux. Phi is equal to 2.26 into 10 raised to 5 Newton meter square per coulomb is the electric flux through that Gaussian surface. So we'll check with the next question. What is it? It's the 15th question and here it goes. A point charge causes an electric flux. So there is a point charge which causes an electric flux of minus 1.0 into 10 raised to 3 Newton meter square per coulomb. So you can see here minus 1.0 into 10 raised to 3. They have mentioned me minus. So minus is nothing but that is a negative sign. So negative sign in the sense what? The force is inward. Okay. And that is the flux is inward, you can say. So 1.0 into 10 raised to 3 Newton meter square per coulomb to pass through a spherical Gaussian surface. So it has to pass through a spherical Gaussian surface of 10 centimeters radius centered on the charge. First thing, if the radius of the Gaussian surface were doubled, okay, if that radius, if it had to be doubled, how much flux would pass through the surface? I have to answer the first question. And what is the value of the point charge? So I have to check what is the value of the point charge, that is Q. Because they have given me the electric flux. We know that the formula flux is phi is equal to Q divided by epsilon naught. I know the value of phi. I know the value of epsilon naught. So we have to just multiply it. I'll get the answer of the point charge. But before that, answering the first question is important. Right. So coming to the solution, what they have given me? They have given me the flux which is phi is equal to minus 1.0 into 10 raised to 3 Newton meter square per coulomb. Okay. So and the Gaussian surface of 10 centimeter radius they have given me. So the radius is how much? 10 centimeter, or you can just take it as 10 into 10 raised to minus 2 meters. Clear. Moving on to the next, what they have said. So first what I have to find out, if the radius of the Gaussian surface were doubled. Okay, if there is a Gaussian surface, then if the radius is doubled, will the flux get affected? I have to find out. So first thing what you have to remember here is, whenever we spoke about the concept, or whenever we discussed about the concept of electric flux, then electric flux is always like, it doesn't change. Okay, but what counts there is the electric charge inside that surface or on the surface. Okay, so that is why electric flux doesn't change. Only if the charges change, that is if the charges are constant, then only then if the charges whatever are there, they have to be constant, or whatever it completely depends on the charges. Okay, that is the radius of the, if the radius is doubled also, the flux completely depends on what? The charges. Okay, so how much flux would pass through the surface, they have asked me. So flux is not related to it. So only thing is that the charges should be, that is the charges will be constant. So flux doesn't get affected. Okay, whatever it may be, like the surface may be doubled, tripled, if the charges will be constant, and what happens, the flux will be the, like you can say the flux doesn't change. Okay, so for the first answer you can just write, if the radius of Gaussian surface, if the radius of Gaussian surface, the radius of Gaussian surface is doubled, then flux passing through the surface remains the same or unchanged, remains constant or unchanged. Why? Because it completely depends on the charge. Okay, so what is the first, that is the logical question it is. So if the radius of the Gaussian surface is doubled, then the flux passing through the surface remains unchanged, because it is completely dependent on the charge which is present on the surface of that conductor. Okay, so after this, next thing what you have to find out, what is the value of the point charge. I have to find out the value of point charge, so we'll do it. Okay, so coming to the next solution, so that is solution B. What is the solution B? I know the flux, that is phi is equal to Q divided by epsilon naught. Okay, so then Q is equal to what? Phi into epsilon naught. Clear? I know the value of phi, which is minus 1.0. So minus 1.0 into 10 raised to 3. And then what about epsilon naught? It is 8.865 into 10 raised to minus 12. Okay, multiplying, I'll get it around minus 8.85 into 10 raised to minus 9. Okay, and what is the SI unit? Nothing, it is Coulomb, because this is the charge Q. Okay, so first what you have to do, phi is equal to Q divided by epsilon naught. Then Q is equal to phi into epsilon naught from this formula itself. We know the value of phi, which is minus 1.0 into 10 raised to 3 into 8.85 into 10 raised to minus 12. So Q is equal to what? Minus 8.85 into 10 raised to minus 9 Coulomb. Okay, so we'll just deal with the next problem now. A conducting sphere of radius 10 centimeters. So there is a conducting sphere of 10 centimeters which has an unknown charge. So you can check that they have given us to find the charge. What is the value of the charge? If the electric field 20 centimeters from the center of the sphere is 1.5 into 10 raised to 3. Okay, so they have given me the electric field which is 20 centimeters away from the center of the sphere is how much? 1.5 into 10 raised to 3. So they have given me the electric field and points radially inwards. So it is inward in the sense the negative sign comes. And what is the net charge on the sphere? I have to check. Okay, moving on to the solution. First thing, right now whatever they have given. So first thing they have given me is the radius, which is r, which is 10 centimeter, or I can just take it as 10 into 10 raised to minus 2 meters, right? And after this they have given me the electric field E, which is 1.5. So it is 1.5 into 10 raised to 3 Newton per Coulomb. Okay, and another one is the sphere, that is the distance from the sphere to the center, which is r. R is given as 20 centimeter, that is 20 into 10 raised to minus 2 meter, or you can just substitute like this: 1 divided by 100, 1 goes, 1s are 2 5s are. Okay, so that will be 1 by 5 meters also, or else it's okay. Like if you are just good with 20 into 10 raised to minus 2 also, it's okay, because you have the powers, right? If you have the powers, you can solve it easily. And points radially inwards. So if there is radial inward force, then it will become minus. What is the net charge on the sphere? I have to find out the net charge on the sphere, that is Q. Okay, so we know the formula for electric field intensity, which is given by E, right? So E is equal to, what is the formula we have? E is equal to 1 divided by 4 pi epsilon naught Q divided by R square, right? Where Q is the charge and R is the distance between the centers of the sphere, right? So we know the value of E, we know the value of 4, we know the value of pi. So we'll just substitute. We have to find out the value of Q. So what happens to Q? Q is equal to 4 pi epsilon naught into R square, okay, into E, right? Because 4 pi epsilon naught R square is here, and multiply it with the E. So after this substituting, what do I get? Q is equal to 4 into 22 by 7 into 8.85 into 10 raised to minus 12, okay, into 0.2 whole square, clear, and into E. What is E? E is minus 1.5 into, so it is 1.5 into 10 raised to 3 newtons. Okay, so solve this and let me know what will be the answer which you get. So Q is equal to, what do I get? 4 into 27 into 8.85 into 10 raised to minus 12. So 0.2 whole square, clear. And after that minus 1.5 into 10 raised to 3. So why did I write 0.2? Because I'll get 0.2 if I solve this 20 into 10 raised to minus 2. Okay, so Q is equal to what I may get? Any answers? Yeah, so Q will be equal to around minus 6.67 into 10 raised to minus 9 Coulomb. So this will be the answer, that is Q is equal to minus 6.67 into 10 raised to minus 9 Coulomb. Why have we taken the negative sign? Because they have clearly mentioned us that the electric field is always pointing inwards. Okay, so that's why we have taken minus 6.67 into 10 raised to minus 9 Coulomb of charge is the value of the point charge which they have set us to find out. So we'll just take the last thing, that is a uniformly charged conducting sphere of 2.4 meter diameter. So they have given me a uniformly charged conducting sphere and it has the diameter as 2.4 meters. Okay, and it has a surface charge density. So surface charge density, where did we learn? We learned it in the continuous charge distribution, right? So we have come across linear charge distribution, linear charge density, surface charge density and volume charge density. So similarly, they have given us one surface charge density which is 80.0 microcoulomb per meter cube. Find the charge on the sphere. I have to find what is the charge on the sphere and also what is the total electric flux leaving the surface of the sphere. Okay, so moving on to the solution, what do we have? So what they have given me in the first case, they have given me the diameter which is D is equal to 2.4 meters. Okay, so we have learned that diameter is nothing but it is 2 times the radius, right? So 2D is equal to what I can write? 2R. Okay, if I want to know what is R, then R is equal to what? D by 2. So what is the value of D? It is 2.4 divided by 2 and I'll get around 1.2 meters. What is this? This is nothing but the radius. R is equal to 1.2 meters. Okay, so I'll just write it in the different color so you people can understand easily. So R is equal to, the value of R is nothing but